Let's now how we can relate one angle to another angle, and we'll see that how the trigonometrical ratios change. So here in this case we are going to talk about sine 90 degree. 90 minus theta means here it is 90 degree minus theta, cos 90 degree minus a, and this is tan 90 degree minus a. We can also say theta also. So in this triangle you are clear that this is the x coordinate and this is the y coordinate. So x coordinate is cosA and y coordinate is sinA. And let's check what will be the x and y coordinates for this point P dash. So we are talking of 90 minus theta, 90 minus a. That means the whole thing is here, it is 90 degree. So up to here only if you talk, this angle is going to be 90 degree minus a. Okay. So for example, if you are talking of the x coordinate, and let's draw a line perpendicular to this x-axis, and then we'll see that what will be the y coordinate and what will be the x coordinate of this point P dash. So here in this case you can see, like if you are talking of 90 minus theta, this angle is 90 minus theta up to from here to here, it is 90 minus a. Sorry, I'm always talking theta. So here it is a. So in this triangle you can see that you can say here it is m. So in the triangle I'm talking of OP dash m. So here if you talk about cos a, means it is cos 90 minus a. Cos 90 minus a is, you know that this is b by h, and we are again taking the unit circle. That means radius of this circle is 1, and hence its hypotenuse will be 1 here. So b in fact is x and h is 1. So x coordinate of P dash is cos 90 minus a. Similarly, we talk about sine 90 minus a, means 90 degree minus a, is p by h, and p in fact is this height, that means the y coordinate. So you can write y coordinate, and h is 1. So y coordinate we have found as it is sine 90 minus a. So let's see here that in place of x coordinate we have cos 90 minus a, and in place of y coordinate for the point P dash, this is sine 90 degree minus a. Let's relate this sort of thing with the another angle a. We are taking the same amount of angle a over here with respect to this angle POX. Alright. So let me talk in this triangle now. So m it is, then you can write here m dash for example if you like. So let's talk in triangle P dash O m dash you can say, or P dash m dash O you can say. Okay, so right angle is m, so you can write P dash m dash O, and in that triangle let's talk about this triangle. What will be the x value? X value in fact is this perpendicular for this angle A. Alright, so what you can write here is that in this case if you write sine A, that is going to be P by S again, P by S again, but now this is in the triangle P dash m dash O, which is here P dash m dash O. Alright, and you can see along this way this is parallel to the x-axis, that and it is stopped here. That means definitely m dash P dash is the x coordinate for the point P dash. So here perpendicular is x. In this case this x and this x are different now, but are the same, but they have been interpreted in different ways, and by 1 that means x coordinate by taking the reference of triangle P dash m dash O is sine A. And if you talk about cos A, in that case cos A is defined as base by hypotenuse, and base you can see that this is along positive y-axis, that is m dash O. Alright, and m dash O is equals to m P dash, which is the y coordinate for the point P dash. In that case, what you can say here is that B as the y coordinate, and then H is the radius of the unit circle, which is 1, and hence y coordinate, in fact, what we have got as cosA. So if you compare point P and P dash, we have the things like in opposite. So what we have got in this case is that in place of x, you can write here now sin A, and in place of y, you can write, look at here, y equals to cos A, so you can write here cos A. Now compare this and this sort of thing. Both are the x, so x equal to x, alright. So what you can see here is that this is x and this is x. So what it is found that cos 90 minus A, so therefore you can say that cos 90 degree minus A equal to x, but x in this case we have found as sin A, so this is sin A, and you can see that sin 90 degree minus A, sin 90 degrees minus A is y in fact, okay, is y in fact, and here also y has been found as cos A. So now you have to remember is that sin 90 degree minus A equals cos 90 degree minus A equals to sin A, and sin 90 degrees minus A equal to cos A. Alright, then what about tan 90 degrees minus A? Just use formula for tan, it is sin 90 degrees minus A, because this is sin theta by cos theta in general, and this is cos 90 degrees minus A. Alright, so sin is defined that way, but just now we have seen that sin 90 degrees minus A equals to cos A. So in place of sin 90 degrees minus A, you can write here cos A, and cos 90 degrees minus A, just now we have seen that this is sin A, so you can, in place of cos 90 degrees minus A, you can write here sin A, and therefore it is found as cos A by sin A is cot A. Okay, so note that cos 90 degree minus A is sin A, sin 90 degrees minus A is cos A, and tan 90 degrees minus A is cot A. We saw that in the first quadrant here, sin 90 degrees minus A equals to cos A, cos 90 degrees minus A equals to sin A, and tan 90 degrees minus A equals to cot A. And similarly you can check for their reciprocals also. Reciprocals in the sense that if it would be cos x CSC, that means cos x, this is 90 degrees minus A, that means it will be 1 by sin 90 degrees minus A, and you know we have here now sin 90 degrees minus A is cos A, so you can write here 1 by cos A equals to, this is sec A. Alright, so similarly you can find for sec 90 degrees minus A will be equals to cosec A, and yes, it is cot now. We cot 90 degrees minus A will be equal to tan A. Similarly, we shall now talk about sin 90 degree plus A, cos 90 degrees plus A, and tan 90 degrees plus A, and the similar way we can see for the 90 degrees plus A angles for their reciprocals. So here sin 90 plus A means in the first quadrant, if you start to count the angle from this x-axis, and then if you go up to the first quadrant, this will describe 90 degree, but we are interested to see the value for or the term for sin 90 degrees plus A, cos 90 degrees plus A, as well as tan 90 degrees plus A. That means any angle more than 90 degree will fall in the second quadrant. Alright, so here we have this angle as A, that means equivalent to this angle. So here we are talking of up to here 90 degree and then plus A up to here. So all together we are talking of this angle. Okay. So let's check what happens here in this triangle. Now this is not necessary to give the name of this triangle. If you are interested, you can write M or something like that, and you say in this triangle, like this is right angle, and go ahead. But you can see it directly also now. So I'm talking in this small triangle here now, that if I talk about the x coordinate, for example, x coordinate is given by this line. You can see in the slightly yellow color. All right. So first of all, we use sine and cosine. So let me use sine. So sine A in this small triangle is P by H, and still this is a unit circle having length 1 centimeter, or you can say in general 1 unit, so that its hypotenuse length is also 1 unit. So let's check what is the perpendicular here. So for this triangle, perpendicular is P dash M, and P dash M belongs to X. That means X is negative in this case because it is behind the Y axis, and H is 1, and therefore you can say that X equals to minus sine A. That means we obtained the X coordinate as minus sine A, that means negative sine A. All right. And let me check for Y coordinates. So it is cos A equals to base by hypotenuse, and base for this triangle is along the positive Y axis, so you can write here Y, and H is in fact, it is again radius of the same unit circle. This is 1 centimeter, so you can write here 1. So you have Y coordinate as cos A. All right. So what we have got in this case is we have got Y coordinate as cos A. Now let's see what happened when you applied 90 degrees plus. Okay, so after being found the X and Y coordinates for this point P dash, when it subtends angle A about the Y axis towards left of it. Okay, but in this case we will not go to that much of geometrical details, although we can, and we have it here, but we can just use some sort of idea that what happened to the coordinates X and Y coordinates when it was P and when it is P dash. So let's check here that if you talk about sine 90 plus A for this position, so at this position you saw when it is sine A, now that is the Y coordinate, and here also this is the Y coordinate, and because of this 90 plus A, it has been now turned to cos A. So you can write here this is cos A, and you know that we have just seen that in the second quadrant sine is positive, so we got the positive value for sine in terms of cos A. Now what happened to this X coordinate and over here X coordinate when it was A and now when it is 90 plus A, that cos A has been turned to negative sine A. So we can write here that cos 90 degree plus A equals to minus sine A, and you know that only the sine and its reciprocal are positive in the second quadrant and rest are negative here. So value of cos in the second quadrant, you saw here that this is negative sine A. Now what about tan 90 plus A? Tan 90 plus A means you can also use this sine 90 degree plus A over cos 90 degrees plus A. No need to go to the figure again, but if you like you can work out for tan 90 degrees plus A also, but it is not required. And we have seen that sine 90 plus A is cos A, and cos 90 plus A is minus sine A. So it is minus cos A by sine A, so it is minus cot A. Alright, so in this way we can find the values of trigonometrical ratios with angle 90 degrees plus A, and also we have to see whether or not this is the meaningful, because sine is positive here in the second quadrant, so we got it is positive, and cos is negative, so we got the value of cos 90 plus A is negative, and also tan is negative in the second quadrant, and therefore tan has also negative value in terms of cot A. Alright, after being explained for the angle 90 degrees plus minus A, now we'll see for the angle of the trigonometrics for 180 degrees minus plus A. Okay, so let's talk about first of all, we have this is the point, and after some times the particle is at this point P dash, which is in second quadrant, because 180 degrees. So up to here you can see here, up to here it is 180 degree, because this is a straight line. And now we talk about sine 180 degree minus theta, for example. That means we talk from angle from here up to here only. So this angle in fact is sine 180 degree minus 1. That means by 180 degree minus A, 180 degree minus A, the position of P will be P dash in the second quadrant, because 180 degree up to 180 degrees in the second quadrant, but negative, it is minus A over here. That means it is still in the second quadrant. So this angle is here. So we relate the angle A in the first quadrant to the second quadrant by taking A angle difference over here. Alright, so in this case let's consider for this angle. You know that at P the x coordinate is cos A and the y coordinate is sin A over here. Now we check for P dash, what would be its x coordinate and what would be its y coordinates. Alright, look at here now. When it was A only, alright, here it is sin A as the y coordinate. Now what happened when it was now, when it is now 180 degrees minus A, the sin A is now become sin A. So sin 180 degree minus A is still it is sin A. Now what about this cos A? So here it is positive cos A. So if you talk about cos 180 degrees minus A, so you can say that here when it was A only, we are taking A only, then x coordinate was cos A. Now when we turn this point up to here by the angle 180 degree minus A in the second quadrant, what we have got actually that this cos A is now it is minus cos A. So what you can write here that cos 180 degree minus A is minus cos A. And also see that here that as we are talking the values or the term in the second quadrant, and you know that in the second quadrant sine is positive, so sine 180 degree minus A is found positive term here, positive sine A, and other ratios like cosine and tangents are negative. So here in this case we saw that the cos value is negative cos A. Cos A, and so that it is minus outside, and sin A by cos A is tan A. So in the second quadrant you know that only sine and cos A are positive, but tan is negative, and we found the same over here. But what happens while we are going through 180 degree minus A, sine is sine, cos is cos, and tan is tan. Only there are few changes in their algebraic sign. And now similarly we can talk about sine 180 degrees plus A, cos 180 degrees plus A, and tan 180 degrees plus A. That means start from here and up to here, this is 180 degree, and plus A means the surplus angle. That will definitely go to the third quadrant. Here also we check for x coordinate as well as for the y coordinates of this point. Now let's check what happens here. We will do the similar work that we did over here. So here in this case, for example, if I am finding sine 180 degrees, now plus it is angle A, let's see what happens when it was A. So in place of sine it was sin A, in place of y coordinate it was sin A. now this sin A has become negative sin A, you can say. So sin 180 degrees plus A is negative sin A. And similarly you can check for cos 180 degrees, and which is the x coordinate of this P dash. And similarly when it was A only, the x coordinate was cos A. Now when it is 180 degrees plus A, the x coordinate is now it is negative. Okay, this is negative cos A, so that it is minus cos A. Alright, and what about tan 180 degrees plus A? So here you can see that tan is ratios of sine and cosine, so it is minus sin A. You can see sine 180 plus A by cos 180 plus A, so it is minus sin A, and this is minus cos A, and negative sign they will cancel each other, so that it is sin A by cos A is tan A. So you know that in the third quadrant tan is positive, that means cosine and sine are negative over here, and same sort of situation we have found here, because 180 degree plus A lies in the third quadrant, and in the third quadrant we found sine as negative and also cosine as negative, but tan as positive. So we are talking in terms of 90 degrees, 180 degrees. So those are actually the standard values in trigonometries, and similarly 270 degrees, and later we'll talk about 360 degrees. So those are also the standard values in the trigonometry, and rest other values within 360 degree or beyond 360 degrees we can deal accordingly. So here now we are talking of sine 270 degrees minus A, and same for cos and tan as well. So 270 degree means up to here this is 90 degree, and up to here it is 180 degree, and plus 90 if you add in 180 degree, that means we have completed the third quadrant. But when we are talking of 270 degrees minus A, then definitely we are in the third quadrant, because up to here it is start from here and up to here we have 270 degrees, and minus A means it is A, that means inside this third quadrant. Alright, so let's check what happens. So P dash, you can say it is M as the foot of the perpendicular over here. So this is angle A and this is angle A here. So from here up to here, if you check, this would be 270 degrees minus A. So because up to here is 270 and up to here A is taken off, so it is minus A, and this is in the second quadrant, remember it. And now we'll find the X and Y coordinates for this P dash. So first of all, in this triangle, so in triangle we can talk in the triangle OM, or you can name anything for the foot of the perpendicular or for the other vertices, OMP dash. Okay, so here let's start from cos or sine, whatever you like. So cos A means we are talking of this angle A in this triangle. So cos A is B by H, and hypotenuse, this is the radius of the unit circle again, so hypotenuse must be 1 here, and B means in the sense that you can say that cos H and B by H. So for this angle A, base is OM, alright, and OM is along Y axis. So what you can write here, this is minus Y. So Y coordinate is, after taking minus to the other side, this is cos A. Alright, Y coordinate. Alright, now let's talk about sine 270 degrees minus A values. And you can see here is that when it was A over here, X coordinate was cos A, but by the rule, if you say 270 degrees minus A, now it is at point P dash, and its sine has become negative cos. Alright, so y coordinate is sin A over here when we consider this angle, and now when it is at P dash where there is 270 degrees minus A, then if it is sin A, now sin A has been turned to negative cos A, so we can write here minus cos A in the third quadrant, and then you'll find that this will be the cot A. You may also work out yourself here. This is cot A, and you know that in the third quadrant tan is positive, so we got tan in terms of positive cot A. Similarly, let's see about sine, cosine and tan 270 degrees plus A. Alright, so up to 270 degrees we are up to the third quadrant. Now 270 degrees plus A means we have advanced to the fourth quadrant over here. So about here we drop the perpendicular on this y-axis, so this is 90 degree over here, and now we are interested to find the coordinate of P dashed in the. Let's talk about now sine 270 degrees, because we are talking of plus A over here, so we can write here sine 270 degrees plus A. So when it was angle A, the y coordinate was sine A, and when it is now 270 degrees plus A, this sine now became, you can see that negative cos A, that is minus cos A. And similarly you can see that cos 270 degrees plus A equals to, now when it was P, then it was cos A according to this angle A. Now when it is 270 plus A, so x coordinate is, now you can see here that this is sin A, that is positive sin A, so we can write here sin A. Alright, so we have already seen that in the fourth quadrant cos is positive but sin and tangents are negative, and therefore what you can find here that yes, tan 270 degrees plus A equals to sin 270 degrees, that is minus cos A, and then cos 270 degrees plus A is sin A, so it is minus cot A. And similarly let's now talk about sin 360 degrees minus A, cos 360 degrees minus A, and tan 360 degrees minus A. Alright, so here we'll do again the same work at this point. So you can say that the whole circle is 360 degrees, but we are taking from here up till here as 360 degrees minus A. So let's check in this, you can, if you like, you can write over here M, because they have the common foot of the perpendiculars here, because these two angles are equal we are taking. So here in this case in triangle we can say it is O, M and P dashed, not P, in P dashed, and this sort of thing is already known. So here it is, you can find it is sin A. Sin A means we are talking of this angle A. Alright, so now let's check sin 360 degrees minus A equals to what happens here. So when it was sin A in the first quadrant, you know, it was sin A, y coordinate. Now this sin A has become negative sin A, and you know in the fourth quadrant only cos is positive, so it is minus sin A. Minus A is minus sin A, so you can write here minus sin A, and then cos 360 degree, because sin 360 degree minus A is tan 360 degrees minus A is sin 360 degree minus A by cos 360 degrees minus A. So in place of cos 360 degrees minus A we have cos A, so we can write here cos A, and we see that it is minus sin A over cos A is tan A, and we found tan A as value of tan is negative in the fourth quadrant. So in this way we can develop the relation between 360 degrees minus A and this angle A. Let's now talk about for 360 degree plus A. So up here you can see we'll do the same work. So what happens here, with this complete circle up to here again it is 360 degrees, and but up to here plus A means we are taking the same angle plus A, then we are again to the point P, that means P and P dash will coincide each other. So directly from this figure we can say that sine 360 degrees plus A is sine A. Alright, because there is no change in y coordinate. When it was A, then it was sine A. Now when it is now 360 degrees plus A, that is it is again in the first quadrant, so sine A is itself sine A. And similarly cos 360 degrees plus A, there will be no change, so that will be cos A again. And then what about this tan A? So tan 360 degrees plus A means this is the ratio of sine and cosine, and hence this is sin A by cos A, and that will be tan